Barons. All right, Gavin and Dean, sorry, we talked about the sweatshirt. Love you guys, but I already closed it. Anyway, if you're curious, come talk to me. Okay, so we have Barons exam. Kiddos collaborated with each other as far as questions that they might have. That's just the strict solutions. This is the actual test itself. And then these are the answers. Let's open up this one because it looks more formal. I'm not sure if it's better or not. Okay, what questions are we stuck on? 6? 32. Let's just go in order. So let's do the first page, which is like 1 through 9-ish or 1 through 8-ish. Number 6. Hold on, 1 through 8-ish. 11 is the next page. Okay. So 1 through 6. In the method of partial fractions, why is this messy? Because this bottom part technically becomes an x times x squared minus 3x plus 2, which becomes just the bottom part, x times x minus 1, x minus 2, right? But what's really nice about each of these parts? They're non-repeating linear, which means true. So can't I go ahead and, when the method of is decomposing one of the fractions obtained, oh man, well I think I kind of have to do all of them because, oh, do I just need to worry about the x minus 1 one? Check it. They just care about this guy. So don't I cover x minus 1, and what do I plug in? 1. So I have 1 times 1 minus 2, which is negative 1. Now I plug into the numerator. What's 2 minus 1? 1 plus 4 is 5. What's the proper numerator? Negative 5. Dun, 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 dun. Double check me, but I think I'm right. Remember, thumb trick. You get to cover and plug in the 0. Yeah? Nice. Okay, anything else on 1 through 8? Next page. I heard number 11. We'll start there. 10 first. Number 10. Is the one I technically kind of had you skip. And the reason is the following. I'm just going to do it quickly. This is technically having you deal with an improper integral. Why is it improper? What's the big deal? This totally looks like something we should be able to do. It's an accumulator function, starting at 5, going to x. And f is the entire accumulator. When it says the domain of f, I'm guessing most of us are stuck on this one, right? Hopefully. If we were to think about f of t being the integrand, f of t being the little dude inside that we would normally love to antiderive if only we knew how. It's not arctangent because it's a minus and a plus. It's not integration by parts unless you want to try. It's not even trig substitution because it doesn't have a Pythagorean relationship. If it was a squared plus u squared, but it's a squared minus u squared without a square root. Maybe we could do something with trig and using trig squared. So maybe trig sub, but for right now, the point is not to solve that nasty integral. The point is to see which of these are true. F of t is 1 over 1 minus t squared, which has roughly, with me doing some approximation techniques, little f, not capital F, little f has vertical asymptotes at 1 or negative 1, little f has vertical asymptotes at 1 or negative 1. They both have horizontal asymptotes going to 0 because going to positive or negative infinity, the bottom wins. And if I plug in like t is 2 or t is negative 2, they're all negative values. So I know pretty quickly the graph looks like that and like that. I can plug in 0 and I end up with 1, so I have that. If I test my concavity, yada, 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 and actually anything in between has to be positive, I'm pretty sure. Anything between negative 1 and 1 would make a positive number. It can't go below. So anyway, I can get this guy's graph at least roughly pretty quickly. So now if I'm thinking of something like capital F is concave upward. Well, wait a minute. Wouldn't I have to find F double prime to do that? What's F single prime? Fundamental theorem of calculus. F single prime would be 1 over 1 minus x squared, which is this guy, right? So what would F double prime be? Well, we could take the derivative, but couldn't we also look at this guy's graph, F prime, and say this is the graph of the derivative? Okay. How do I visualize second derivatives on first derivative graphs? Slopes. So question, will the slopes always be positive? AKA, will the second derivatives always be positive? I believe I see some negative slopes. Or you could take the second derivative and realize that sometimes that second derivative is a negative number. If the second derivative can ever be a negative, this function is not always concave up. So right away, process of elimination, not E, not D. Okay. F of 2, wouldn't that be the area under the curve from 5 to 2? Awkward, negative 2 to 5. So negative, hey guys, 2 to 5, isn't it already going to be a negative number? What's the negative times a negative? A positive. Oh, that's true. You didn't even need to know improper integrals, but I know some of you were curious and you were wanting to know whether or not this is true. And a lot of you thought this was true because you said, vertical asymptotes, true of this. But if he has vertical asymptotes, you can't have an integral going to a vertical asymptote. That doesn't make, ooh. Yes, you can, and it's called improper integrals in section 9.3, something we haven't covered yet. Do you see why I said you could skip number 10? You could have made the proper match without even thinking about this, but a lot of you made the mistake of saying, yeah, the integrand has vertical asymptotes. So true. It's not talking about little f, it's talking about big F. So all of a sudden we're introduced to this idea of you can have area going to a vertical asymptote that equals a number? Maybe. Yeah. Worked out, put E.
I believe so.
Does this not have all the answers? Oh, here you go. Whoop. For x greater than 1. Wait a minute, hold on. Did I miss a domain thing? Yeah, they're saying it's E. Hold on, x greater than 1. Why is it x greater than 1? Did both answer keys say E?
Yeah, I'm looking at the answer key and then the first one's no, the second and third are yes.
Hold on, they're saying x greater than 1. I'm just trying to figure out why they're limiting the domain, because I didn't. But if you limit the domain, yeah, you're fine.
They're not saying that the x.
It doesn't say F is concave upward everywhere. I assumed it meant everywhere. But I'm just not seeing where the x greater than 1 is being stated anywhere. X greater than 1. I mean, it's true for x greater than 1, but why x greater than 1? Oh, they're having us totally ignore the vertical asymptotes. This is a BC exam, right, guys? Not an AB?
Yeah, BC practice examination 3.
Go down outside.
Potato tater, it's the same thing.
Oh, 1 and 3 are very tied though, because 3 is true in the sense of the slopes are all positive greater than 1. So if we determine that this domain is greater than 1, it's concave up there, just not over here. But the domain comes back to this. This said that the domain is all real numbers, but 1 and negative 1. They're saying the domain is strictly greater than 1. So they're saying that we shouldn't even be thinking of other values. They're basically cutting it off at the first asymptote, because from 5 they're going to the first asymptote and stopping. That's awkward. Okay. I raised the point that there are these things called improper integrals that let us deal with vertical asymptotes and see whether or not the area exists, and I said it's possible for a definite integral up to a vertical asymptote to have a constant area. The long story short from what they're showing is that if we were to actually do the improper integral, it does end up being infinite, which means I can't possibly like say infinite and then keep going past that. I should say negative infinite, no, positive infinite, because it's 5 backwards. So they're saying once you learn section 9.3 and once you could deal with this improper integral, aka a bound of an asymptote, that you wouldn't keep going, and so thus you would ignore all of that. Right. Still, it has to do with S going to 9.3. So based on what you know, you should have gotten this. But based on what we're about to learn, you would actually deal with the vertical asymptotes and then realize our restricted domain. They didn't do the improper because you guys haven't learned it. Bummer. Okay, so it's E, but still we were supposed to skip it. Long story short. Okay, number 11. As the tides change, the water level is a sinusoid. Oh, sinusoid. Okay, so we know at 8 a.m. Any physics people make the x-axis T. Just kidding, we should have all done that. We have T, and then we have H for the height of the wave, and then we have like 8 a.m. Sure, why not? We have 15 feet. Sure, okay. And then we have at low tide, 6 hours later, here-ish, there's 2 p.m., which is the same thing as what, 14 in Army time? It was at 3 feet. Anybody think that maybe they needed to go back to pre-cal a little bit? And they were asking how fast in feet per hour was the water level dropping at noon. So noon would be somewhere in between, specifically where in between? What was it? 8? 4? Like there. And they said dropping, which means I'm supposed to think all of those are negative. So now it's a dilemma of, well, sync, what's the slope of that tangent line? Well, I don't know unless I know the function. And I can take its derivative. So way back when, we learned that you could talk about something like the middle of the curve, halfway between 3 and 15 is 9. Y equals D plus amplitude. How amped up is this wave? Well, from that 9, doesn't he go up 6, down 6? Can't I talk about him like a cosine curve because he starts at the top? Can't I talk about his period by saying that 8 to 14 is half a cycle? So that 6, 12 is the total period. And so I can make my period being 2 pi over b, which would be pi over 6. And then I could do my theta or my x minus, he was shifted 8. Oh, awkward. You could have made an equation of the sinusoid. And if you made an equation of the sinusoid, couldn't you just do y prime at, I made him 8, right? So then noon would be 12. So it's derivative of cosine? Negative sine of u. I'm plugging in 12 times u prime, which would be pi over 6. Is that right? And so 12 minus 8 is 4. 4 over, that's 2 pi over 3. Sine of 2 pi over 3 would be square root of 3 over 2 times negative 6 times pi over 6. Those would reduce, and I would end up with negative root 3 over 2 pi. Oh, but dropping is the negative. So root 3 over 2 pi. Oh, double checking. B? Yep.
Wait, is the x minus 8 within the cosine? Or is it like outside? And the y is
I didn't show the grouping symbols, but it's cosine of b times x minus 0.
Have there any question like this?
I haven't seen any recently. I think this is back when pre-cal was more involved. I mean, it's helpful to have that skill, but I haven't seen them make you make a sinusoid recently. But still interesting. But yeah. What ends up being like, wait a minute, they make you make sinusoids and all this pre-cal stuff? I haven't seen it really recently. Anything else on this page? Cool. Woo! Can't we take the derivative of both sides to get rid of the integral because we're snazzy like that? And we can do calculus and the derivative from any a to x is equal to f of x. Oh! So f of anything is just 1. Double check, is it D?
No, it's A.
So what happened? Oh, I didn't see the sign. Sorry. My bad. There's more than just the x. I don't know why, I just ignored that. Pause. What's the derivative of this thing? Product rule, right? Second be first. Okay, plus first be second. Come on, you guys have read a problem wrong at least once in your life. Now what? So sine of 3 pi is 0, because sine of any pi is 0. And then, because I'm doing f of 3 now, right? And that's 3. Cosine of 3 pi is negative 1 times pi. Look at them. They had it all ready for someone who didn't read the function. That's awkward. Who made that mistake? Anyway.
On the typed
Yeah.
solution, it says B.
But on the written one, it says A.
How about on the answer key one? Do you guys agree with the answer key is A?
The answer key is
Okay,
A.
so the typed one, something went wrong. We had to grade it first, and then I know. Not everyone's perfect.
I still got it wrong.
Oh, well, you needed to get to f, and f was present inside an integral. So just like with anything, like in pre-cal today, we totally had to solve this. How do you get to an x? You always have to do the inverse, right? So if it was x squared, square root. If it's sine of x, sine inverse. If it's the integral of, take a derivative. You can always... no, see, look. You were used to the accumulator. So you were thinking capital F, and they were asking capital F, but you had to do some algebra. Well, calculus, well. Okay, anything else on this page? Next page. Wait, which one? 20? 20 and 23?
Did you know that everyone sees color?
We're going to end on this page. You guys are going to turn it in. I'm going to grade just see your attempt by the end of the day, and then we can go over more questions the next couple of days. Sound good?
Yeah.
So number 17 is asking about this dude being rotated about the x-axis. I know just based on him having a square root, the domain is x greater than 0. It's a lot more obvious than the one we saw a second ago. And we have x equals 1. I know this is somewhat some sort of like dude like that, and then x equals 1 is somewhere here. And if I plug in 0, there's a vertical asymptote, so that's kind of awkward, so let's leave him there. And then, oh, x equals q is in between 0 and 1. Sorry, they gave me a domain. Okay, what else? So I'm going to here, and I'm rotating about the x-axis as q goes to, ooh, this is nice. They're teaching you how to do an improper integral before you really know how to do it, because they're saying make the bottom bound a variable and then have it approach 0 from the other end. Because otherwise it'd be an area making a volume towards an asymptote. This was another improper integral. We'll save him. He's an improper integral. Man, we need to learn section 9.3. Because he looked like something that we could do, but he's another improper integral. We'll come back to him. You guys also said 20 and 23, right? Why is number 20? Why are you able to eliminate him real fast? Wait a minute. It's saying true, not false. Uh-oh. And why am I going to say this one is true? Horizontal asymptote, limit to infinity, degree test, who wins? Top. And if the top wins, there is no horizontal asymptote. That's true. Number 2, the line x equals 2 is a vertical asymptote. Is it a discontinuity? Yes. Is it able to be removed? No. Is it a vertical asymptote? Yes, it is. It's a non-removable discontinuity. The line y equals x plus 2 is an oblique asymptote. Oh, you had to remember the 14 identifiers from last year, because whenever the top wins by 1, we can always go looking for oblique asymptotes, because oblique asymptotes are the little linear portions that result from an improper fractions division, ignoring the remainders. Oh wait, actually, hold on, pause, we can keep going. So 2 It's 2x minus 4. Remainder is 4. Woo! 1 and 2 and 3 are all true. And then number 23. I think this one is a party if I remember right. It's a good one, and I likes him, but he's going to take some time. All right, we're cutting it off anyway. I'm cutting it off on number 23. We'll pick up with 23 tomorrow. You guys turn it into the tray by the end of the day, but for right now, can we just go straight to chapter 9? I want to at least show you how to do homework tonight in the next 7 minutes. If you guys have it ready at the end of class, just pop up, put it in your tray. If you have scratch paper, staple it before you put it in the tray. Sound good? Okay. Chapter 9. Yesterday. Nope. Friday. Convergence of a sequence. Most important time to say it is today. Convergence of a sequence. A sequence of real numbers is said to converge if the terms in that sequence eventually stabilize towards some single limiting value, aka not infinity, not negative infinity, but stabilizing towards some single constant. Otherwise, we say the sequence diverges. Convergent behavior of a sequence in decimal form can be seen as more and more decimal places become fixed. Sometimes this takes a long time, but you kind of see like one decimal and then a few more as you're plugging in 1.9, 1.99, 1.99. No, sorry, convergence. As you're going to infinity, as you're plugging in 10, then 100, then 1,000, then a million. If you see the decimal places start to become fixed, and like yes, there is some variation, but certain decimal places are sticking around, you can also see convergence that way. If a function is bounded and monotonic, bounded, aka cannot go to infinity or negative infinity, and monotonic, strictly increasing or strictly decreasing, then that function must converge. If a sequence is convergent, then it must be bounded. It cannot be going to infinity. The converse of the statement is not true. Converse is flipping it around, right? Sequences that do not have limits diverge. What do I mean by limits? Does everything have a limit besides the awkward oscillating DNE? We're not going to negative infinity because we don't have negative terms of this sequence. But we do have positive, and they can just keep on, remember, comma, dot, 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 keep going. So the limit as n goes to infinity of the sequence, a sub n, if it equals, or does not equal, some constant, L, then it will diverge. Then it will diverge. Now, there's a lot of information on this page. Some of you might want to take, what am I trying to say? Screenshot of it, possibly. You can access it online. Also true. However, what I want us to do right now is do some practice. Now, here's a quick dilemma. We're already kind of behind, but I think Barron's was an important thing for us to do. And some of the other discussion was also useful. I want us to zoom in on at least starting the examples. I think for homework, it's not super crucial that you've done all of our practice. This is more for like the chapter 9s of other books that are getting really, or that are forming the foundation for all that crazy stuff that's to come. So I'm not sure if you totally need all of this, but I do have a lot of practice, and I do think it's helpful for us to do. So I'm going to make the homework due Wednesday, turned in at, but you need to start it tonight, okay?
Yeah.
But just so you have some sort of idea as far as starting, if this shows up. If it says throughout the first 4 terms of the sequence, you would start at, let's just all start together unless the book says otherwise. We're starting for n equals 1. Okay? But then you could just go ahead and do like 1 over 1. Remember, sequences are separated by, the terms are separated by commas, right? So it'd be 1, then it'd be 1/2, then it'd be 1/3, then it'd be 1/4. Okay, that's the sequence. Series would have additions in between and have a big old sigma in front. But my question to you is, does this sequence converge or diverge? because the limit as n goes to infinity of the nth term 1 over n equals,
0.
which is a constant in any sequence
Not series.
whose limit equals a constant, does in fact converge. So can you find me one on this page that does not converge? Actually, D does converge because the limit, that's a good idea, is just awkward. But it is a constant, right? Keep looking. Nope, because C also, remember, degrees are tied. F is a constant. F! Good. Now, it's not E, because even though this one is forever alternating, going back and forth and back and forth, what's 1 over n stabilized to? 0. But what does n minus 1 over n stabilize to? Alternating. The signs are going back and forth and back and forth. And as the signs are going back and forth and back and forth, the whole thing is going to 1. So awkwardly, isn't this whole thing going closer and closer to 1 and then negative 1 and then 1 and then negative 1 and then 1 and then negative 1 for forever? Is it ever going to make up its mind? Nope, because of this alternator guy. This is a true divergent, divergent sequence.
Not
series.
Now, if we're talking about the series, if we put big old sigmas in front of all of these, that one would still diverge, that one would now diverge, that one would diverge, that one would diverge, that one might converge. Actually, he doesn't. He diverges too, and that one does converge. Out of the entire thing, if these were series, this would be the only convergent.
Not sequence.
Yeah, not sequence. Sequences are so much
Not
easier
Series.
because all you gotta do is ask yourself, does the limit exist and is it a constant? Wait. So is this homework necessarily super crazy intense and awkward and out there?
Hopefully not.
So you're just really practicing limits. So why is section 9.2 L'Hopital?
What? Special.
Because, well, it's helping us with special limits, number 1, but number 2, it's also making us more capable in limits for the awkward things to come. Which you guys hopefully should already know, so it's not a big deal, it's more like review. You might want to take a picture of this one, it's going to be an endeavor card, and I don't know if we're at number 10 or number 11. Oh no, I think we're beyond number 11.
Mike,
12.
Endeavor number 12.
Wait.
The previous
I don't
one
have
was
enough space on my phone. I think it worked.
Endeavor number 12.
I don't have enough.
We'll figure it out. Now let's take the endeavor today. How about
I
that?
know for sure it's 12.
I'm confused because he said the last one.
The last one was
The last
11.
trying to do
The
it
last
right.
one was off. Because the last one we had, we skipped. And I think the last one was 11.
Yeah, I don't know what
I'm
you said.
hungry.
This entire period.
Last one was supposed to be 10, but you like
Yeah, the last one's supposed to be 10.
Oh, but I wrote 11?
Yeah.
My numbering's off? Just kidding.
Oh man,
Thanks, Kevin.
If it says 10 on the PowerPoint and 11.
that's so.
Oh, well, this was from last year. That's why it's like and I think we added a card this year. Take another one. Just kidding. We'll try to figure it out. I'll have the endeavors updated so you can look at it tomorrow. Bye, guys.
I can't even see that.
Ben, front, end of day.
Sorry, you're.
Barron's front, end of day.
Yeah.